in order, again, I mean, to address the important challenges of CO2 emissions. And let's say on the side note, which is not really a side note, frankly speaking, it's like with road safety is very important for us. I mean, 24 seconds you get somebody, dying on the road, okay, because of accident, injuries, and so on. So we believe that we can kill two birds, okay, with addressing CO2 emissions within, smart city, and of course, increasing the road safety and increasing the traffic flow management. So that's the rationale, and this is the target for us. We are people, designing the next generation digital infrastructure. So you see what I call usually the magic behind the curtain, because not everybody is talking about it. Okay, when you see a robot, when you see a self-driving car, we don't really think about the infrastructure which is supporting actually these challenges. And again, for us, this is the backbone for many of the vertical services which are changing the life of citizens in the future, not only again transportation, okay, but it could be energy with smart metering, smart grids, waste management. I think many of you have been in the IoT business. Okay, so the backbone is definitely digital infrastructure. It should be smart, of course, sustainable, autonomous, and electrified, okay, for the sustainability. This is coming then from all the different sensors. Somebody was asking me a question this morning. All the different sensors which are being deployed within the infrastructure. That's more easy. Of course, this is an investment, but the return of our investment is massive. Okay, so these sensors, okay, it could be like radar, LiDAR, video cameras from CCTV, for instance. So this is where basically you can also choose the location of these sensors in order to support this road safety and many of different verticals. All these sensors on the edge, of course, this is generating a lot of data, right? You need to acquire all these informations. So point of cloud, for instance, when you get LiDAR, or all different images, okay, with video cameras. So of course you can compress information, and the trend is to put more AI on the edge. I think it was mentioned yesterday, okay, in order to avoid, sending the raw information directly, okay, to the cloud. But in any case, this is going to generate massive more data. Okay, so how to address this demand, this capacity crunch somehow, okay, from the digital infrastructure? This is basically why we're also working on 5G Advanced and 6G technology, in order to take that natively from the beginning, okay, in order, to address it. Addressing it means getting technologies that will enable higher data rates from order of magnitude, okay, so with the 6G, that between 50 or 100 times in terms of peak data rate, for instance, so reaching terabit per second, reducing the latency for getting, let's say, communication with devices and with, for instance, vehicles. So all of this is what we call basically the collective intelligence. And this is really, yesterday was mentioned a paradigm shift. This is a paradigm shift, okay? Again, natively, you are going to address AI within the networks, and you are going to address, all these sensors and how we are going to collaborate together, okay? So this is the collective intelligence that you see on the pyramid of the 6G, right? And the sensing on the base of the pyramid, which is basically, the sensors I was talking about, this perception layer, which is being distributed, within the smart city. So 6G is definitely a business game changer, again, thanks to native AI and also, Open RAN, which is our positioning for us. Another important, measure of what's happening there for us is the US Department of Transportation. V2X was started to be deployed in China. We have a lot of lengthy discussions in Europe, okay, regarding CV2X, regarding DSRC in terms of technology. Well, US is making it happening. This is what I call the time for action. Okay, with the creation of ARPA-I for the infrastructure, with massive investments, with the waivers, okay, with the FCC. So this is something which is happening, deployment, because we understand the value, again, of a digital infrastructure for the backbone of many services and business. Part of the challenges that are going to be addressed, as you see on the right-hand side, you see, IoT, AI, machine learning, of course, connectivity, cybersecurity, no need to mention that. That's part of my center. When you deploy an infrastructure, you want to make sure, again, that this is safe and secured, okay, from the cybersecurity point of view, in order to enable businesses, and in order to make sure that people can trust this business. So another important technology I was mentioning about, this is CV2X, so cellular vehicle to everything, okay, vehicle to vehicle, vehicle to infrastructure, okay, to the network. So you see on the left-hand side, this is a picture, okay, illustrating, okay, the architecture and the use cases, because even though you can put many LiDAR, video cameras on a vehicle, if it is standalone, if it is alone, okay, in the street, that's not enough, because you always find, use cases, scenarios where you get a blind curve, when you get, a blind, a line of sight because of a truck or something like that. So what you have to get is collaboration again. You have to get many sensors, within the infrastructure, capturing and collecting, aggregating the information, and of course, broadcasting this information to the right vehicles or even pedestrian or what we call the roadside units from the infrastructure. And this is the collaboration that you need to make sure if you want, again, to secure road safety first. Then, on a side note, of course, once you reach the road safety, then you will improve the traffic flow management for the freight and for people. And if you see, this is an outcome from a TNO, survey regarding just one of the scenario, which is intelligent intersection. Just with intelligent intersection and this technology, we could note like around 20%, reduction in CO2 emissions. So this is just a tip of the iceberg of what can be done in terms of benefits, again, regarding the CO2 emissions. So with the Gen AI, basically what we believe is the rise of generative AI in testing, validation, for instance, for standardization, validation that we were talking about, yesterday, right? Because here you can see, for instance, on the left-hand side, what we call the strive attack. This is where Gen AI is going to generate colliding trajectories. So basically, they are generating many different trajectories, okay, for what we call the adversary, vehicle. The planner is basically the green, vehicle, which is your vehicle, for instance. And of course, one of the trajectory will include a collision. Once you get that, well, you can optimize. Okay, you can make sure that you will avoid this collision. This is a kind of adversarial optimization. Important point for us, again, this is how to standardize, how to make sure that the AI algorithms, okay, either onboarded within the vehicle or from the digital infrastructure will avoid, okay, this collision. And of course, that can be compared, benchmarked with Apple, with other vendors' algorithms, for instance, and make sure that you have the validation of your technology. And this is where, again, we believe that Gen AI is going to transform really the automotive industry, because you can improve the AI safety, you can benchmark it, you can validate it, thanks to test and validation. So SIL, HIL, this is software in the loop, hardware in the loop, and this is what we do, for instance, with digital twin that I'm going to discuss about in a few minutes. Standardization, again, this is where basically there should be a paradigm shift, okay, and this is something which is happening with one of the IEEE, P2846, working group, where here, again, Gen AI, we believe, will help in order to, again, to identify use cases, scenarios. As you could see on the bottom, there are two scenarios, like the car following scenario or the pedestrian following scenarios. So you need to identify the corner cases, the edge cases that, well, as a human being, basically, you're not going to spot what kind of scenario is really tricky, for instance. And on top of that, the Gen AI, it can help to identify the right parameters. Because then this is all about it. Like, what are the assumptions? What are the parameters that you need to benchmark with other vendors' algorithms? It's all about that standardization. You want to make sure that you have something which is where you reach a consensus among vendors, among the industry, and that you can benchmark, again, apple to apple. So another aspect of trajectory prediction this time, okay, so this is, you see on the left-hand side, these are, agreed, scenarios like the jaywalker. There are many of them in Paris, jaywalking, merging into crowded traffic, merging into high-speed traffic, or the famous multiple lane changing, okay, for the motorway. And here you see with a multimodal transformer, okay, again, we can predict and can generate multiple hypotheses for the trajectories, and of course, find the right one, avoiding collision. Then it's all about what I'm mentioning here, inference time. So how you run the algorithms, and you need, well, to be fast if you want to make sure that this algorithm is avoiding collision, of course. But again, we strongly believe that with processing units which are improving, well, this is something that will happen. I remember many years ago with the IoT, when we are discussing machine learning on the IoT devices, some people were skeptic, but this is happening, because of course you make improvement in terms of the model size, in terms of quantization, etc. And TinyML is, a strong movement for putting more and more machine learning on the IoT devices. The same is happening here, okay? You will get Gen AI on smartphones, you could see that Mobile World Congress on smartphones, on laptops. Of course, it's not the 180 billion parameter, but the size of the model, of course, is important. But this is something happening. you will manage to get that. So for us, again, that's important, okay, also to make sure that we have the right process. So this is a classical project for us within TII, where basically you see here, this is for the merging lane. Okay, we have a perception layer within the roadside unit with LiDAR, with a camera, and we aggregate the data of the vehicles. We are making training thanks to the data set. Once we get that, we are making simulations. So simple simulation first on the left-hand side, on the bottom, simple simulations. And then once we reach maturity on the performance, we go for digital twins. Okay, so digital twins is an important feature of the research and the engineering because it's going to be synthetic data for the trainings, more and more accurate, so it will save time, it will save money. And then you can, of course, benchmark the performance of your algorithms with multiple use cases scenarios, and especially the corner case scenarios, where you can give a rain, you can, increase the traffic, jaywalking. So digital twin is very important for this part, okay, of the design, the development, and the validation. And here we managed to show and to demonstrate for us, then on the testbed development and then on the field trial, that not only we avoid the road collisions, of course, with the lane merging, but then we improve the traffic flow. This is always the two elements which is important. The digital twin, again, I'm here, the generative AI is going to help a lot in terms of not only the simulation itself, but also to build them. Okay, so designing digital twin will be enhanced thanks to Gen AI. This was just here on the right-hand side, a digital twin powered already by ChatGPT. Okay, so this is again just the beginning, right? But it will help not only for the video itself, but also to design, to develop an entire and very time-to-market digital twin here. So these are on the left-hand side, a couple of digital twin that we are using from our side. As I said, okay, with the smart cities or construction sites, or with Cyrodiil with the radio planning, for instance. And here we are connecting each of them together because getting a single digital twin is also a challenge. But this is a must-have if you want to make sure that you can have software in the loop testing, validation, and of course then hardware in the loop testing and validation. So what we are doing here, within our center now with the network for Gen AI, what we call network for Gen AI, is building a communication and computing framework. We are doing telecommunications, right? So we'll get a multi-agent distributed environment, okay, with LLMs, and then we need to understand how we are going to communicate with each other, what kind of information, basically the protocol itself, okay, and then, as I was mentioning, this is how to bring this collective intelligence, how we are going to collaborate, and this is the tricky point. But this is what we call, the multi-agent, of course, LLM, or also the large, action models, where we believe it will make, a difference. So you see on the right-hand side, this is, let's say, the high-level architecture for this agent. Okay, so you get a device LLM, so LLMs on devices. Okay, and as always, I would say for agents, you get a perception layer, which could be anything from the sensors, right? And then you get an action layer, because you need to trigger actions. It could be sending a message, it could be holding the wheel, accelerating, if you get that on the vehicles, or just, switching on, the light, if it is the traffic light on the roadside units. Of course, then you get some principles and concepts coming from LLMs, like the knowledge, okay, for instance, you get the memory. And for us, telecommunication part, we need to make sure this is, again, communicating with each other. So we get the wireless environment for these multiple generative agents. One of the applications, which is very promising for us, this is, again, the intent-driven autonomous networks. So we had, self-organizing networks in 4G, okay, and here what we are targeting is full autonomous, right? So which means from automation, we move to autonomy. From the plan by rules, we go for the plan by reasoning, and you see basically here the breakdown of the task for each of the agents within the network, the breakdown, the chain of thoughts, okay, that we are going to identify, and behind this task breakdown, we are going to trigger communications. So the right-hand side, this is what we call the emergent protocols. You have two nodes, so two agents communicating with each other. So first of all, sharing their own capabilities with the other agent, because this could be different, and this would be different models of LLM, different branding, different capabilities. So we need to understand, okay, who is around, okay, for the communication. So that's the basics of protocol again, but we start with that. And then it's like, okay, thanks to the task breakdown, okay, I'm going to do this, you are going to do that, and this is how the collaboration is happening, So Open RAN is quite actually a good playground for us, okay, for implementing that. The next step for us with the multi-agent LLM, okay, this is what I call the Gen AI on wheels and infrastructure. Okay, on wheels, if you put that on vehicles, so it could be a car, a truck, I mean, an e-bike, whatever, depending again on the size of the LLM, and you get the infrastructure. And you see here, well, Falcon LLM, okay, was within the vehicle, and you see all the roadside units is interacting with them, you know. So the roadside unit could be a traffic light, okay, saying, well, status is red. Okay, you get a camera showing and seeing the vulnerable road users, so basically the pedestrian, and all of this is communicating and taking his own action. And taking own action could be part of the CV2X, okay, this protocol of telecommunication, broadcasting messages to the right units. And all of this, for us, this is the bet that we have, okay, that's this part of Gen AI, of the LLMs, okay, we bring more context. We'll be able to gather, to understand more new context, okay, within their environment, and could be the missing link towards L5. L5 is really, I mean, the last final stage of automation level, okay, within the self-driving. You see construction site is the roadside unit, and it's communicating, seeing, collecting what it's seeing, you know, and you get the explainability part as well, which is always missing. Explainability because you get the chain of thoughts, the task breakdowns, really mentioning what I'm going to do and why I'm going to do that. So this is a bit a high level, okay, architecture, but basically, okay, well, here you recognize the agent, okay, with the fusion, the perception layer, the action, I mean, the reasoning, and all of that, again, are going to discuss with each other, okay, and saying what I'm going to do. Why? Okay, because I see this, I see the traffic light, I see vulnerable real user. So the next action I'm going to take is this. And we are going to communicate. Important aspect, the semantic channel. Here we see what we call a semantic communication, I mean, within the telecommunication arena. Okay, this is something which is still a bit early stage. So there is the debate if it will be part of 6G or not. You know, sometimes if it's just mature enough, well, you need maybe to wait the 6G advanced. But this is something which is very promising because, again, instead of sending data, I mean, bit fields, then you are just sharing the semantic part of the communication. So in order to understand the semantic part, okay, I'm going to show that, I mean, just right here. Okay, this is the semantic transmission of information. So you have, for instance, an image, and really, I mean, with the current technology, like Llama adapter, you can transform this image with just text. The text is explaining what it's seeing. Okay, the image features a white truck, okay, driving down. Yep, I don't know what's happening. Okay, so this part of the information, this text, basically is a semantic representation of the image. And you just have to send this text over the air, over the wireless channel. So this is less information. And once you get that, you can regenerate the image based on that. So here we see, for instance, infrastructure to vehicle. Here, this is an example of vehicle to vehicle where the camera from the vehicle is seeing this truck here with the road walking, you know, and again, it will say, it will identify that like a white pickup truck loaded with roadwork equipment, including etc. Okay, this is again the semantic information and sending that to other vehicles. Of course, semantic information is much more than that. Okay, this is an illustration because it's difficult to capture actually all the mathematics then behind it. But here is just a simple use case and illustration what semantic is about, and where you could see that instead of sending the whole image or video, you can send just the semantic part. You know. So an important aspect I wanted to mention here while speaking multi-agent LLMs on wheels or for infrastructure, we see the market. Market is always, you know, important measure for sanity check. So you see Neuro, for instance, or Ghost Autonomy, or Wave, okay, which are right now working on that. So which means it's not the LLM alone, this is part of the puzzle. Okay, so this is an additional layer which is going, of course, to interact with the already existing self-driving stack. I mean, software, okay, developed mostly with deep learning, okay? But this will give you, I mean, indication, okay? So you see for the Wave, I'm slowing down and get to stop because I don't have the right of way, etc. So it's not only a chatbot, okay? Clearly not. This is indication. These are the task breakdown I was speaking about, you know. So then we have, okay, for us, we go down then in the communication arena. We are building foundation model, okay, with Gen AI, with multimodal wireless data. Still nothing. Okay. I hope that you can hear me. Okay. I've tried to be loud. Okay. So we are generating this foundation model. Okay, with multimodal wireless data. Sorry. Is it okay for you? Or okay. So we can carry on now. Okay. Thanks. Huh? So and then we generalize that to various applications and scenarios. So basically, you see from the sensing side, because 6G will be all about sensing and communication. Thanks to many technologies. So from sensing, we can detect or recognize objects, for instance. We can, track the location of objects, like with the IoT, for instance, and we can visualize the environment. For the communication part, this is about prediction of beamforming, for instance, okay, or resource allocation, or radio map and network planning. So this is an example, a tip of the iceberg, what we do, for instance, here with the wireless sensing part, okay, which is a keystone for 5G advanced 6G, okay. We are leveraging multimodal raw data, so just the data, the raw data from the devices, okay, in terms of radio environment. And thanks to GenAI, we are capable of building the image of the environment. So you see, the ground truth is a reality, okay, so buildings around the device, okay, with in white, okay, and generated, this is what we are able to reconstruct, to rebuild, just based on signal radio, okay. So it's kind of radar, okay, I would say, in terms of wireless sensing. But the good point for us is that could be quite interesting for many applications, okay, especially if you, of course, if you don't have any LiDAR, video cameras on small robots, because it's too costly in terms of power, maybe money, in terms of the place, okay, to put on the robot. But the robot is always connected, okay, so which means it can receive signal radio, okay, and thanks to that, you can rebuild the environment, and potentially you can use, that information for, again, positioning the robot within his own environment, okay, instead of leveraging, okay, the video or the LiDAR, for instance. Then I was speaking beamforming prediction. So this is something that we are doing for a key technology in wireless communication system, which is RIS, or Reconfigurable Intelligent Surface, or holographic MIMO. This is based on meta surface. Meta surface, you're just shooting on, unit elements within your matrix of the antenna, and you need intelligence behind it. Okay, so it's kind of mirror, okay, for the radio propagation, right? And you need intelligence for that. Okay, and this intelligence, basically, we are capable. This is something we demonstrated 2 years ago. We are capable of predicting fastly the beam itself. So beam tracking, okay, the device, which was the vehicle, based again on multimodal, data. Multimodal means you are reusing, video cameras, radar, LiDAR, even GNSS or initial measurement units all together with the data fusion, and the AI based on GenAI, okay, will actually predict which beam, okay, you need to use, okay, for tracking the vehicle. Another important aspect in terms of GenAI, shift, this will be the command and control center, because when you're deploying intelligent transport system, you always get this command and control center. So, yeah. So briefly, of course, we're working on that, especially the teleoperation, which is important for us. Teleoperation means you are capable of handling and managing the end-to-end latency. And for this optimization, again, we are using GenAI there. Initially, we're not using that. Okay, it was really optimization with more classical ML techniques. And now we are shifting again to LLMs in order, again, to reuse only the semantic information for optimizing the parameters. So immersive video streaming for volumetric environment, this is basically how to ensure end-to-end latency and quality of your video, right? And the video for us within the command and control center is not only 2D screen, this is now virtual reality, which means you can have a look in 6 dimensions. Where we see now, the first element and achievements with GenAI actually improving the process. Another aspect is the cross-modality, which means for the command and control center, when you get a user with multiple screens, it's not easy, basically, to look at what's happening, okay? So sometimes, if you have an image and you get, thanks to an LLM, like image bind, for instance, thanks to that, you can have the representation with text, like what's happening, in order, to write the reports, or let's say to generate an image just based on sound. If you get only, sound, devices and sensors within your smart city, it can still generate an image for the end user within the command control center to show him like what's happening, just based on sound. So this is something that needs to now to be taken into account within the command and control center, especially in terms of user interaction. For urbanism and architecture, so I'm not an architect, okay, for that part, but for sure we can see, everybody can see, okay, these huge improvements, okay, giving the context, okay, for the buildings. So this is something again which is happening and will be improved. Another aspect important for us is the building information management. These are the BIM platforms are being used actually for urban planning, okay, and there is a kind of language, right? This is a language for, again, managing and designing, okay, the scenarios there. And once you get to, a language, well, LLMs is taking place, So there is already, some preliminary, solutions there, okay, with LLMs and GenAI, okay, for improving, so assisting again, it's kind of companion for assisting, okay, the end user, to create and to get faster, okay, for using the BIM platforms. So the transition, when I speak, coding, for instance, software code, I was mentioning that yesterday within the panel. Okay, for us, we have a cybersecurity unit. When you deploy the complete infrastructure, not only with devices, but also with core networks, with, base stations, etc., you always get software everywhere, okay? And software, it's important to make sure, okay, that there is no vulnerabilities. So the starting point for that, this is software code generation. So first, it will improve, of course, the time to market development, right? So you could see it was statistic from last year, I think, like 35% of the user of GitHub Copilot, it helps them to code faster, okay? But it's not ultimate. It's not generating code which is bulletproof, okay, in terms of vulnerabilities. And this is where we are in action, okay? For us, cybersecurity means we should make sure that the software, especially for critical infrastructure, there is no vulnerabilities. Because vulnerabilities, weaknesses means this is a loophole, okay, for attackers, okay, for hacking systems, So this is what we want to get. And for us, we already demonstrated, end of last year, okay, that thanks to our secure Falcon, okay, based on Falcon LLM, we're able to classify binary 92%, okay, of the software source code, which means binary classification means vulnerable or not vulnerable. In March this year, we had multi-classification, which means it's not only vulnerable or not vulnerable, it's like when it is vulnerable, we are able to identify what are the weaknesses, to classify them. And this is a big improvement. Once you get that, so here is just an example of the user interface. You put your software here, the source code, like it could be like a companion if you want, okay, initially. You can identify, classify vulnerabilities, and then it will tell you all about this vulnerability. Then the second point is explanation. To explain the vulnerability, right, and to provide explanation. This is the second step. Once you manage to do that, that means you are close to the self-healing. Because the self-healing, this is, once you get the classification and the explainability, then you can really identify what part of the code and how you need to repair it. And this is what we already demonstrated slightly end of last year. And now we are working hard, okay, to get more than Tier 4 in terms of product, okay, by end of this year, to get the self-healing for each of the code generated, C++ and Python. So this is the global architecture. So it could be part of a module where you plug that within an IDE, okay, so basically an environment for development, and then you can use, again, a code generator, whatever it is, okay, to be agnostic to that, okay, in order to self-heal, okay, the software. And then this is something important in terms of milestone, in order, again, to deploy only non-vulnerable software. Another aspect, again, of GenAI and LLMs, this is what we call a network intrusion detection system. So here, not only the software, it's at the network level. We want to make sure whenever an attack is happening, whenever somebody is trying to intrude within your system, you detect it, you classify, and of course, you take action. And here with BERT this time, okay, it's not Falcon, but with Security BERT, we managed to do that. We managed, end of last year, to demonstrate that we can detect more than 98% among the 14 most important attacks of the network level. Now this year, what we do, because we are an applied research center, okay, we are porting that within devices, within gateways, and we are running, real-time attacks, okay, and we already demonstrated that we managed to do that with a couple of attacks this year in March. The good point for us is that our algorithm is small, so we always mention the size of the algorithm, so especially with AI. It's small enough, it's fast in terms of inference time, because if you want to detect an attack, you cannot wait 2 hours. It should be very fast to detect, to classify, and to trigger action. So this is what we call the shield AI for us. Adversarial attacks, again, within AI, this is just to, again, identify by cybersecurity, where is a new domain once AI is happening. Okay, these are well-famous, attacks. Okay, for instance, with face detection, what we call liveness anti-spoofing. Okay, for vehicles, if you want to detect who is driving the car, for many reasons. Okay, you want to make sure that if you show just a picture, okay, on the paper, or if you want a picture on the smartphone or video on the smartphone, well, your algorithm is able to detect, well, no, this is just BS, okay? You are trying to hack me, okay? So this is something which is already there, for a couple of years. The same for attacking, AI on the sensor type, where basically you can inject, you can have what we call Troy AI, okay? So basically you are injecting, you are dealing with messing up with the dataset itself, okay, with the training. Okay, so our teams are working on that, like how to attack AI system, and of course, how to mitigate these attacks. And this is, Etsy is addressing that. There is a standard which is addressing and listing all the different attacks. And now with LLMs and GenAI, well, you are going a step further. Okay, LLMs, GenAI is something new. Okay, so that was OWASP listing like around the 10 most important attacks with LLM, right? Like prompt injection, of course, the same for training data poisoning, which is classical. But what I wanted to highlight is that at the end of the day, right now, most of the attacks were classical attacks with denial of service, so it's like start to be secured first with classical, approach, and then, of course, you need to address, well, the new ones like prompt injection, for instance. But you could see on the open source community, which is very important for us, you see rising stars like Giscard, PromptMap, Garak, which are addressing how to assess, how to evaluate your LLMs. So it's kind of pen testing also somehow. And pen testing, this is one of the last points I wanted to mention. Okay, when you are addressing cybersecurity, it's important to assess your system, evaluate the system, right? And this is what it's doing with pen testing. So here we have a solution that we call Falco Pilot. Falco Pilot is, again, a companion. It's a companion and assistant for your security expert, which is going to automate, okay, the reporting, going to automate identification, of course, the network, vulnerabilities, and telling you what you should do, in order, again, to save time, and also to save those sources, because it's always a bit difficult to find real expert in the domain, for many companies. So here, it's important to get such kind of companion and assistance. So again, that's what the part of rise of generative AI in the testing. Well, I'm going to finish, of course, on EU AI Acts. I'm not going to dive into that. This is like I think from 2 years ago. And here, it was just, a preliminary assessment that they published regarding the ongoing, at that time, models like OpenAI, Anthropic, etc. And they were just comparing like where they stand, okay, with respect to this in terms of data sources, governance, copyright data, etc. Of course, copyrighted data, which was the obvious part, okay, at that time. I think it's still ongoing with many actions, okay, in court. So the debate, of course, is like regulate, not regulate. That is the question, as I said. I think it's not completely finished and how to do that. But, okay, I'm not a big regulator guy, okay? I like standardization, validation, okay? Regulation, I think need to be careful about it because it could, of course, it could slow down the innovation, okay? So we need to always find trade-off, to find the trade-off and to reach consensus. Thank you for your attention this morning.